Welcome everybody, and welcome to join Dr. Luan's meetup. Dr. Luan, this is all yours.
Sure.
So the recording just started.
So thank you. First of all, thank you very much for inviting me to present one of my research on this channel. First of all, my name is Howard Nguyen. I graduated from Harvard University of Science and Technology in Pennsylvania on 2024 December. And this is one of my research I want to present to all of you today. It regarding to heart disease predictions, which I use like all of like machine learning, the popular machine learning, deep learning, neural networks, and my stacking generative AI model to predict the heart disease. The agenda today is like include with like introductions, motivation and public burdens, literature reviews, research objective and key question, methodology, datasets and pre-processings, and model architectures, result, key finding and clinical significance, future work and limitation, conclusion, contact, and demonstration live for near the end of the presentation. First of all, I want to kind of a little bit introduce and here for regarding like kind of like we all know about this, but the heart disease almost like 32% in among with all other disease. So it's like the most popular and the leading cause of death in many other disease. So the most popular is like ischemic heart disease. And it's included with the heart, the stroke, heart, heart failures and CVDs and CAD, like coronary or artery disease. That's the most popular. It's included inside like ischemic like heart disease. So I can say that just like a heart disease. And strokes is the second most popular in here. So that's why like. And the third one is HSD, like hypertension, hypertensive heart disease. And it's very important for and the disease in among with other disease. So it's captured to like about like 32%. And a little chart in here to show us in America, like it's still in growing and growing because of the age we aging. Like 2020, it's like 6.7, but 10 years later, it's like increased like 2 million. The next 10 years later, it's increased like almost 2 million. And the following 10 year, 2050, is about like more than 1 million of the American people. So the continuous with the resources like what motivate me to do it, and then based on the public health burdens, I see in here like more than 64 million people affects globally annually, and within 30 days after they hospitalized, there is a readmission like 20%, 25%. So that's 1/4 people like discharged from hospital and then they have to come back to readmit again. That's a very high readmission rate. And the current problem for in the clinic or hospital or the healthcare system right now is we see the challenges like the data is not balanced and it's very limited with the subgroup data. And assistance current machine learning and deep learning model is like insufficient for generalization, and this is not balanced. So the gap is like we need the balance to the tool to balance the data and interpret interpretable model, to like easy for people to understand and make that scalable. So my motivation on the research is like to build accurate, robust predictive model to save life and to reduce the healthcare costs. And on my research, I do a lot of review on the literatures, like more than 100 of them. And I do like for four different groups. The first group is like traditional kind of like the research is based on like how to do like prediction to build the predicted model for heart disease. And I look into like four groups. First group is like a traditional machine learning model. The most popular in here is like logistic regression, random forest, gradient boosting machine, extreme gradient boosting machine. And the strong point there is like a simple. These model are simple and it's easy to implement, and interpretability is good. But the limitation is like difficult to handle with non-linear relationships inside the data pattern, and the imbalance data, especially in the healthcare data, is very hard to make the balance to the data with the like imbalance data sets, and scalability is very limited. And the second group is like the new network is considered as like a deep learning model. Example in here, like I look into for those using CNN and RNN to build the predictive model for heart disease. The strong point there is like they can capture complex the data pattern, but the limit is it's causing a lot of like running on the server. So it's relating to the computational cost. It increased a lot, and lack of like interpretability. And the third group is like I look into like the third group is like they many of like author they use machine learning based machine learning traditional machine learning to stacking together. So that's good too. So and because it integrates with multiple algorithms, so that's why it compensates for individual witness. So it improves a lot on the accuracy and the error under the curve matrix. But the limitation that they still see the imbalance data. So it have to be like using some of like method to do the balance data to get better. So that's why three groups, and I see also like another groups is like generative AI by GAN. Like GAN is like stand for generative adversarial networks, and it's really good to address into it solve the problem of like a class imbalance and generates the synthetic data. It's very high quality in synthetic data, and that's really good. As we see in here at the table, the accuracy, the methods and the accuracy level is reached into the level, and interpretability as well. But interpretability, we can use the other third party in order to like LLM model in order to improve the understanding the results from the algorithm to return. And to continue with the literature review, so that's like this is just very small one to do summarize all of that. Like existing model struggle with class imbalance and general abilities, but my stacking generative AI model resolve both problem through the synthetic augmentation and hybrid architecture. As you see on the far right little bit here, the architecture combine between, as you see in here, very small one, combine machine learning, deep learning, and GAN, and stacking them together and evaluate them and generate the results. And just to continue for that is like the research objectives and key question. So in the research, in the research, all we have with like the objectives and the question is what for. Objective is like in here to compare with all the machine learning, deep learning, and the model is kind of popular model with the one I create for it in order to evaluate the best result for the heart disease. That's the objectives. And the question in here, I come up with like 5 different questions. Like how do we know, how do we evaluate the machine learning versus with like deep learning model, which one is the better individually? And also like the second one is like the second question is like what is the most predictor type influence, like what is the what is the most influent predictor for heart disease? And the third one is like stacking model with base model only, like traditional model only, and to compare with individual model, if that's good or better or no good. And the fourth question in my research is like how to improve when we incorporate the model, individual model with the generative AI. And the last one is like the biggest question is like what contribution can the stacking model to contribute to the healthcare? So that's the biggest question. So far, do you have any question? And then I can just jump in.
Yes, I saw a question from Ron. Was the same data used to train the 4 different approaches?
Oh, it is I do jump or it auto jump. I don't know. Hold on. Okay. Because I see on the screen, but what the question again?
The questions on the chat. Ron asked, was the same data used to train the 4 different approaches?
The chat. Where I see the chat.
The chat is on the screen.
Okay, were the same data used to train the 4 different processes? Yes. The answer is yes. I will show you the table and then you will see exactly like the answer is more detailed. Any other question?
Not yet. I just got a compliment. Really looking forward to this presentation. Familiar with ultrasound detection, some lab tests. Just a very good comment.
Yeah.
Hello,
Can you continue or just wait for other question?
Can you hear me? I got a small question there.
Okay.
It's just for me for my learning. What type of input data that you use to train the system? Are you using based on symptoms of the patients and the effects of symptoms and to train the system? I mean, when the patient they feel something in their heart and as a symptom, and then that information combined with the later stage of development of heart disease, you combine that data as part of material for training the the ML and your network systems?
Oh, okay. It's very interesting question. Yes, but after you see all of all the step I saw in here, then you will totally understand that right away. And then that's one is like the question regarding to like the results when we do like kind of real time with the healthcare system. That is just like for the academic level, and the second level will be like integrate with the EHR or the healthcare system database, and then it will be like return real time to the patient results, maybe on the computer or on the mobile phones. Yeah,
Thank you.
yeah. I will show you at the end of here, and then you will see this like what's going next. Yeah. Um, so if no more question, I want to continue with this. Okay. And for this one, it's like, so now we jump in from like the objectives and the question of the question kind of like when we do any research, we have to have the like, base the core question in order to answer in order to deeper dive inside the result research of the result. And methodology pipeline is like for the processing on here, what I've been doing. So first of all, like datasets I use like 9 different datasets, very diverse and diversity. It's from like 229 to 400K records. And pre-processing like kind of like every data is like never has like clean data. So we have to do like cleaning and normalizations and apply with the SMOTE and GAN to do the synthetic data generation. The model I use applied like logistic regression, random forest, gradient boosting machine, extreme gradient boosting machine, convolutional neural networks, recurrent neural networks, and GANs like generative adversarial networks and stacking generative AI hybrids. And then when we apply the model on the data sets, and I do like optimize and validate it. Optimize by like adjust the hyper parameters to make it better, and then if the results is no good, we have to like tune in again. And after tuning done, we do like a cross validation to validate that model is made sure the model is not overfitting issue or underfitting issue. And the final step is like evaluation. That's the result we get. And the tool I use like kind of like here a lot of like different tool, but I saw in here just a few. And then also like I use like 100% on the Google Colab and by GPU model GPU T4 that the paid version. And the evaluation matrix is like all of like accuracy, ROC AUC, precision, recall, F1 score, ANOVA validation. And the next one is like from here to here. I want to show like a little bit on the datasets and pre-processing process. I divide into like 3 different groups, like small, medium, and large. A small one is about like 1,000 records and less. And the medium size data set is between like above 1,000 and less than about 10,000. And the last one is like about 10,000 records. And as we see in here, like the attribute or feature or variable in here, we see like the most popular is like age, gender, blood pressure, chest pain, cholesterol, and medium size. I see like it have more data like BMI, smoking status, diabetes, And the loss side, I see more data is like with the plus with EHR, like electronic health records and medication status, like people take the medication or not, something like that. And for regarding this is like pairing between SMOTE and GAN level. It's SMOTE when I use the SMOTE in order to do like kind of like basic synthesis data generation, but that is just for a small data set. And the SMOTE is not good than than the GAN in order to apply for the larger data sets. I have to compare with like GAN as well. So see like from to compare like when I use the same data sets, the same that means like 9 different data sets, apply SMOTE and apply GAN. I see like improve when I use GAN methods. It's improved to from like 83% to like 95%. And a little box in the right side in here, we see like a data processing pipeline, kind of like the same process, but that's like every data when we use, we have to do apply in this process. It data cleaning and with the missing data imputation and normalization, class balancing very important, and splitting down like trend test splits like 80-20 ratio, to stratification. And then these reprocessing done, and then we get ready to apply the machine learning model on the data sets. So far, any question? Or I can continue with this.
So the question about your data pre-processing, so there's two phases. That one, when you begin your project, there's possibly a step where you have to decide what features or tokens in your data set are going to be relevant or going to be used in your in your project. And the second form is once you're going and you're updating data, you basically skip that step because you've already selected your features. How did you go through that process of selecting your features, and how did you do that?
First, like we need to take a look on like kind of like cleanup data, right? And then if like missing data because the calculation cannot calculate with the no value in data set. And we have to like do like all the cleaning and missing imputation in here and class balancing in here and make it ready. So your question is like you do like all the thing here at the end for all of data sets, or
No, at the very beginning of your process, you have to decide what features of the data or what tokens in a instance record you're going to use as part of your project. If you've got hundreds of thousands of tokens, you may not want to use all of them because many of them may be irrelevant.
That's correct. Yes, that is a very good question, Ron. Thank you. You may select like 10 or 20 or 30 or about like 40 different attributes or variable. You can consider a variable or attributes. And you should do when the data, and then you select like 40 different column, right? And then you do like, you evaluate by doing like co-relevance. That's mean like it relevance with like CBD or heart attack, and then you have like age, you select like age, BMI, diabetes, like smoking status, like education level, heart rate, kind of like that. And then you select, you think first, you think like you can test like many different, because like your data sets look like very huge, like more than 100 attributes. So you don't know which one is which one. But I recommend you should like, because I used to work with like cardiologists in to get the knowledge from the kind of like domain knowledge expert, and then they will give you the idea of like what is relating to what the attribute most relating to the heart disease. Are you looking for to do with the strokes? Or are you looking for to do with heart failure? Or are you looking to do with like heart attack? Yeah. So many different kind, and then different kind of like the output, and which one, what attribute is associated with the output. So you need to consult with the cardiologist, one of cardiologists, and then he will tell you. And then you, at the time, you select the whatever's on the attribute in order to make up like a good data set, and then you do you apply model on the good data set you already select. It does the answer for you.
Yeah, I mean, so if you had the case where you started out with 500 columns, and in 40 to 50 columns for training is a pretty good target. But how do you break the 500 columns down into 40 and get the best? It's an N of M problem. How do you get the best 40 out of 500 columns that will give you the best accuracy for your model? And typically you would start with a covariant matrix, but
Yeah.
so it sounds like you said that. So very interesting. Thank you.
Yeah, that's the one I do in order to like to see, let's say like let me show you very quick in here. I can show you. Yeah, this is the one kind of like, and then when you see like even like 100 of attributes, so you will see like called relevance. Yeah, called relevance, and then you will see it, and then which one you don't want, you just remove it. And then this kind of data, so you can do like 100 of column to do in this methods. Yeah. And then you should, yeah, again, with like work close with like domain expert, domain expert as well.
Thank you.
A similar question there. Well, when you got all these variables, did you define yourself the independent and dependent variables? And also, are all this data just a kind of static data, or is a kind of temporal data which is associated with the evolution of the diseases?
Okay. So when you do correlation matrix, that's one. And the second thing you should do like feature engineering. Do you know feature engineering in order to let me show you that one as well. And then you will know what is right here. Yeah, this called a feature important. It's called a feature important or feature engineering. So you will see like what attribute will cause in it most relating to like heart attack. They say like most relating to heart attack. So the BMI and age category, age range, and angina, general health, and gender, stroke, and sleep hour. This evaluation in order to know what attributes associate most with like heart attack. So that's like feature important you can generate for this.
So you define which. So by doing that, this process would allow you to separate those variables which are dependent and from the one which are independent and more influential.
Right.
That's
Yeah.
what you're saying. And then
Yeah.
I did ask also if your data is a kind of static data. So you got the data from a single patient on a defined time or defined date, or is that kind of data evolutionary data where you got data from patients which have been progressing, the illness had been progressing over the years, so that you'll see how the temporal effect of these parameters.
That's the different story too. Yeah. So this is like we train on the static data, right? The data set is like this data set in this case is static. But in your case, you mentioned like let's say for example, like one patient go into the hospital and his or her records already in the hospital, and then how it's relating to in order to send the result to the application, right? So that's use case will be like answer like when because I plan to do with like cooperate with like one of cardiologists to build an application and implement application direct into his hospital. And when the user when one patient go into the hospital, he or she will do like go around to check up and then get out, and then at the end of the road she will get the result. So the percentage like of like I may I skip a little bit in order to like at the end when I do like a demo app, and then I will show you on that one as well because it's related to the healthcare system.
But it's fine. It's okay. You carry on. Yeah, we can explain it
Yeah.
later.
Yeah, because that's exactly I love that question as well. Yeah. Because that's the next step of this. So because like when we do this one to evaluate the whole this one the research in here in order to 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 make sure that to understand that my model, the model we apply in here is the best model in order to later on we can apply into the clinical setting. So that's the purpose. But later on, when we apply with the clinical setting, and that's the real hospital system, healthcare system, so that will be the different story as well, but kind of similar with this.
Actually, I saw a question earlier from Pierre. He asked, "Did you try train a validation set or test split or k-fold cross validation?"
Um, Question on which one, Helen?
The question is from Pierre. Maybe Pierre can unmute. Can you unmute, Pierre? His question is, did you try train validation sets or test splits or k-fold cross validation?
Oh, uh, um, evaluation. Okay, do on the test, but evaluation and test validation on the training data set. Yeah.
Let's move on. Yeah, thank you.
Yeah. Thank you. Okay, just keep going on. It's like after data sets processing, and then so now we discuss about the model architecture. The model architecture, like I introduced previously, like again, like generative adversarial networks. That's like as we see in here for both. In GAN network, it have the two network. One is generator network, and the second one is discriminator network. And when the data received into generator network, it generates the synthetic data. Let's say, like for example, like we have 1,000 data records of data, and 10% of them is like have the had positives of like the disease, and 90% of them not positive. So that's why like it's unbalanced. So now we have to generate like 80% of like the minority of 10% plus 80 to become like 90, and the other like non-positive is like 90, so it's equal. So when the generator network in here generates like 80% new synthetic data, so they become like 90. So and the second step on the GAN network is like the discriminator network. We'll see like, okay, now is have like 180. So it's not like 100 anymore. So it's now is 180 records of data. And then the discriminator network has the function to discriminators to find out which one is the real and which one is unreal. Which one the unreal is considered like synthetic data. So, but through the GAN network, generator network, it generates it very good quality of the data, because like generates by a new network, and it's very hard to detect by the discriminator network. So that's this turn out the outcome is very high quality of synthetic data. So, and then after synthetic data, and then you see in here, this one is the whole process I develop and do, and we see in here the GAN network, we do generator and discriminator networks done, and we do it like train the GAN model, generate the synthetic data, and combine the synthetic data with the original data, and split into testing and training set, and combine with 3 different training-based model, and to stacking all of them together. And this process it takes a while to return the result. And at the end, we get the result for the we will see the accuracy, precision, recall, and F1, and also like plot the receiving operating characteristics curve, area under the curve as well. And we see this, and we got the output. And in here, for the benefits, yeah, and we see like when we apply the GAN network in, it's like improve the unbalanced data, and reduce overfittings, cross-validation during stacking, and provide the confidence score for clinical interpretation. And it maintains like 91, 98% accuracy across the 9 diverse data sets. And at the final, I received the ROC AUCs of 93 and 99% accuracy when applied on the 400,000 record data set, and improve representation of minority subgroup. It's very important and very good when we apply the GAN network and to stack with the other model. And the results in here is like, as I compare the result in here, this is the text, and this is the ROC curve. So you see in here, it's kind of small. But the results in here, I can show you in here. For the small data sets, you see 5 different data sets in here, like 1,000 and less, and more than 1,000, about 10,000, and last one is just like 70,000 to 400K in here. So the proposals like the Stacking Generative AI model in here, usually is like outperform to compare with all of the individual model in here. So this table can answer one of like the question from previous one of you asked, like to apply to apply the same method to all different data sets. This is the answer yet. In order to compare, we have to do it exactly the same. And when we apply exactly the same data sets and we apply the model on the same data set, and then return the result for that. And I also like compare with the current research out there on the literature research, and with the latest for those who use in exactly the same data set as well. Many of them use the same data sets as I do. So we can compare with the result over there and compare with the generative AI models, which is stuck in with the base model, machine learning model out here. Yeah. So far, any question?
Yes, I noticed a question from T. Venick. She asked, are you finding particular types of data or data calculations more useful in determining types of HF, such as hypertrophic, obstructive cardiomyopathy?
Very interesting. Yeah, thank you. Particular type of data and data calculation determine type of heart failure. The answer is like, I don't have that particular data sets. 9 data sets in here I use to evaluation, like 11 model in here, the kind of the public data sets. And this data sets from CDC, the data sets from the other public, but European, and there's for American data sets. But it's a public data set. It's not like from like ESR data set yet. That's what I'm looking for, to have like one of like ESR data sets, and then I can apply into this. But like particular for and calculation, when we have like the data sets, or when we have the when we want to apply a model into the ESR data sets, for example, like that, we need to know what we want to do first, and then we would like evaluate with the outputs, like the heart failures or strokes or heart attacks, 3 kind like that, right? And then which one is what predictor or what attributes associated with that mass, and then we will calculate based on the output of that, based on the results of like heart attacks or stroke or heart failure. But right now,
yeah. Sorry, excuse me. Sorry, that makes perfect sense. And by looking at the different types of heart failure, there are different models. Like when you have a heart attack, that's the small blood vessels that supply oxygenated blood to the heart muscle itself, so that the heart muscle can work, so that you don't get the equivalent of a Charlie horse in your heart, that pain in your heart. But with heart failure, very often it's a matter of the heart muscle itself grows, and it reduces the flow of blood through the heart. And so that's a different type of heart failure. And so that will necessarily be a different type of calculations. NIH has been doing a lot of work on this for the past about 7 to 10 years. And so this is fascinating. I mean, to be able to take a data set and be able to predict and help those smaller hospitals in more rural areas that do not have access to the type of equipment you need. This is phenomenal. And has been so much research in heart failure recently. This is really going to help. So, so thank you so much. I'm really enjoying your presentation, but it's small.
Thank you very much. So you know what? I'm very happy if you want to cooperate with me, and then I can help you with that. So to implement, like when you have the data, and then you want to calculate like what attribute, what feature, and what predictor you want to calculate, and then to get the result for the what kind of a heart failure, what kind of heart attack, and what kind of a disease with that. Because if I have data, I can do it for you. I can help you with that. Yeah.
This is just wonderful.
Mm-hmm.
I'm going to tell a couple of cardiologists, and I'm going to see if I can get you a contact at NIH.
Sure. Yeah. Thank you.
Thank you so much.
Yeah. Thank you.
And I noticed a question from Bobby. Any books or resources that you recommend for a beginner to learn more on ML for healthcare? It's interesting.
Any book for resource that you recommend for beginner? Oh, a lot. I have a lot of books, but I use the pack. What it does? I use pack, and then I pay for pack like pack, right? PACKTPUP.com, and also like a lot of like different book for machine learning, deep learning, data science, and kind of computer books from the beginning to intermediate and advanced level. I can text in here for this in the chat. Book resource. Yeah, I put in the chat the book resource. So far, any other question? And then
very noble work. There's a quick comment from Ron.
Ron, okay, I have demonstrated a quantum algorithm that performs well at selecting the best 40 column from original 400 column set. The results train ML stack based on the 40 column actually outperform ML train for all 400. Yes. If the datasets for this presentation is open source, I may be interested to do on this. Yes. I have to step out. Okay. For the site. Yeah. Ron Snyder can connect with me, and then I can share the data with this. The answer is yes, Ron. Okay. I think I can continue a few more. So after we have the result over here, we see the difference in the performance of the and the importance of why we do the stacking model each other. It's kind of a little bit heavy, but the output is like very important. This next step is like key findings, clinical significance, like this kind of the what I kind of one of like what I get from this research. As we see here, like the Stacking Generative AI, like our performance to compare with all other individual model. Which one I applied to 9 different datasets. And for this one only, but the other one I do apply, I have tried apply with the same way. With 11 model, I do apply with like diabetes datasets and lung cancer datasets as well, and kidney failure as well. It's worked very well. Not only just like 9 datasets in here. So that proves that like the stacking generative AI model is very good right now. And the most influential predictors of the heart disease, I can see in here, like primary is the age. When we get an age older, it's like the more serious like heart disease problem it may have. So this is the result. And the BMI and systolis, diastolis, that belong to the blood pressure. And the secondary predictors kind of like cholesterol level. If higher, we have big problem. And the symptom is like chest pain. If we have the chest pains, it twisted at the bottom or chest pain inside the heart, that's a big problem as well. And clinical applications, like we can apply in the clinical setting is like early risk stratification, to identify the high risk patient before symptom onset. And the ESR integration, that's the future I'm looking to. And the personalized treatment, like when we know the issue, we can like personalized treatment for the heart disease people. And the resource allocation, and future works and limitation. Future works, the model is good, but it have a lot of work for for the real worlds in there. But first, like the first we talking about here is like for the limitation. It's like potential bias in generated synthetic data. It may be, but that's like when we do with when we work in like data science, the first thing first is like the bias problem, and then that's the concerns all of the data scientists. And so that's why I do test, and validate to make sure like the results is like confidently we can say to the world. Yes. So that's the limitation, but we can overcome that. And the limits with external validations across diverse patient populations and computation intensities of combined stacking model. It's kind of like I mentioned before, when we stack it all together, it's a little bit heavy, but I run on my PC personal computer, but it still runs good. So, but I just pay a little buck for Google to run on CPU, GPU, not CPU. So it runs well. So that's mean like when we apply on the clinical setting, so we run on a private server, so it won't have problem with that. And the future resource directions and clinical partnerships, that's like ESR integration and model monitoring is kind of belong to the future resource direction as well, to implement the model into the real world for the hospitals to use, for especially in America and here. I also like work with like cardiologists to he showed me many different tools out there. They do the evaluation for heart disease for people, and then I test, and though current model they're using in America right now, it's like 55 to 75 accuracy level. No one reaching into the 80 accuracy level. Wow, that's like I tell them. So that's mean like we need to do more in order to get into the markets, especially in America over here. And conclusion and contact in here. So first, again, it's a 98% accuracy and 99% performance well metrics on the AUC area under the curve and test on the 9 data sets. Yeah, and the hybrid approach is very effective address for the heart disease challenge to fix the problem from the other model is like for imbalanced data and scalability and generalized abilities. Generalized abilities that is very, very important because like if we many author out there, they just try to test only one data set. When the model apply onto one data set only, so that means it cannot confirm that work well on the other data sets. So that means like generalized ability. So that means like can apply to any data sets. The model, if the good model, it have to be like applied to any data sets, not just only one or two. So yeah. And clinical impact like enable personalized care through accurate risk stratification and support data-driven decision-making in clinical setting and provide frameworks in early intervention and improve outcome. So here is my contact information, like just like info@harvardmin.com. My first name and last name.com. It's very simple. And so any question, and then I can answer before I jump to the demo.
A question, would you consider diet as a predator? Like some people have a vegetarian diet, some people don't have a vegetarian diet. So will diet be a consideration? Heart failure?
Heart failure, what? Pardon me, can you?
Will you consider diet, the diets, like some people only eat vegetable and some people eat meat? So people who eat meat have higher chance to get heart disease, that kind of thing.
Oh, okay. On the demo, I will show you.
Sure, thank you.
Yeah. Very, very good question, but on the demo, I will show you.
Yeah, I got another question if it's okay to ask.
Yeah.
It's two questions. One is to do with synthetic data. So I suppose most of the data that you've used is data from clinic, real data. I wonder if you have considered synthetic data and compare with real data, how they correlate. That's my first question. And my second question is we users of AI, some of us, we are a bit skeptical about AI in a sense that we regard AI as a black box. We don't know exactly what is doing in the black box. So I wonder in your work whether there's a possibility of cross-checking or auditing the AI itself. For instance, for example, if you had a chance of looking at the probability density functions of those different variable, different parameters, and to see those probability density functions from the AI compare with probability density functions calculated, obtained from other methods to see if AI is doing exactly what's supposed to do.
Not even better. So if you apply the AI in, but the results is not better, so they will ask you back why we use the AI, because if no any better than the normal like calculation like Excel doing, so why we use the AI? So
No, I'm not saying that. I'm not undermining or trying to diminish the contribution of AI. I'm trying to transparency. I'm looking for transparency.
Yes. Yeah.
That's my question. It's transparency to see what exactly is doing. The output. I'm happy. I think most of us were happy.
Yeah. So you know what? Yeah. You have two questions, right? The first question is like for you mean the to apply
Synthetic data.
synthetic data in the real data sets inside the healthcare system. In the healthcare system, it have the live data and the dynamic data in there. And the data in there, the data is like you have, for example, you have like 1 million records, and just like 5% of the 1 million records is have like heart disease, and 95% it don't have. So, but if you want to train the data for 1 million records, you don't need to train for the 1 million records. You need to just like pick a randomly, like let's say like 200,000 records that are really good for training the model for the new network model. A new network model, they love to have like to train on like more than 100,000 records. That is very good enough already. You don't need to like real apply to the real. When you apply the kind of like this, right? When you build an application in order to like apply for your real world, and that's the difference with the when you apply the methodology on the data sets, and that to become a return on like whenever user go in and they capture the real of her or his or her records and return the result. That's the difference. But the app for using is separate. For training is different. So, but for the training and for the generate the synthetic data is the same thing. But the two things are different work on the different scenario. But for the to generate the synthetic data is the same methods we do. When you generate the synthetic data, you apply the GAN method in, and then it generates for you. The quality is, let's say, like, I can show you a little bit in here as well. What did I generate? Yeah, this is, for example, like you see that's 13,000 with to compare with this one. This is the after we this is synthetic.
You're not sharing. We cannot see.
Oh, I no longer share. I share the screen, not share the.
It's on conclusions and contents is the slide I'm seeing.
Yeah, I see.
Okay.
Because I share the. How can I share screen? Not share, just share the application. Okay, hold on. I do it back. Desktop one. Yeah. Okay. I believe so. You can see. You can see, right? Can you see?
Still conclusions and contents.
Oh, hold on. I need to apply it. I need to share.
There you go. We see the chart.
Okay, that's good. That's what I want to say. So this is the bar chart, right? So you see the before Yan, it's just only one test. It's only 13,000. And when we do like synthetic point, we do the 95% calculate that 95% generate. This is synthetic data in order to balance with this one. So this and plus this equal with this. So when you see this one, synthetic data, it's like generates from the real data. So you see that it's kind of similar, but it's like the methods of like GAN network is like new network is very good enough to like mimic. So for discriminator network, it's very hard for them to identify if the real or no real. So that's the purpose. That's it really good. So when you generate the data, it's kind of very heavy, but it's good to apply any machine learning model in. You see this after I do the generate synthetic data, and then I apply the model in. Does I answer your first question?
Yes, fine. That's good. Thank you.
Yeah, and then later on, if you want to contact me, and then
Yeah.
I happy to work with you with that. So yeah, and then I go work you with, because this one is like very limited in the time. Yeah.
My second question is about the transparency of the AI.
Transparency AI, that's like if you are head department of the AI and then you want to implement any AI tool or any AI methodology on the spec, because data is the backbone of the business. So many people, especially like manage the database and very conservatives and like very skeptical, they don't want to change. If you want to apply the AI in, it's kind of like very careful and ethical and governance data, and you have to work with kind of like create a steering committee, to explain to all of them what the AI doing, what it does, what the AI for, and what it is doing, and what it like. You have to like transparent all of every detail in very detail. So like the one I'm doing for my corporation right now, is very detailed in front of like steering committee. If you don't have a steering committee yet, so you need to like invite those people, type like decision maker in like business or is CEO, CFO, or data team, data kind of CTO, CIO, some people like that, to like you present to them, here is what the AI tool I want um, to implement into our system, and what it is, and then what it's doing, and what is like what the result we expecting to get, and how do we implement it, and how long is like implementation, and what is process, and who involved in that, and the manpower. So it's very detailed for kind of like the business plan for you to implement. So you may get approval for that. Otherwise, it's very hard. So
You need to be able to show them comparisons, like this is the way that you used to do it, and this is doing it with AI, and this is what we get. And you can see the difference in the time that it took to do the calculations and the accuracy. You're seeing much greater accuracy, and they still don't believe it, but they'll start to move toward it. So
if you, it's again like some of the reason many people don't want to change. That's the core reason as well. So that's why you need to set up a steering committee. In that steering committee, you show them all what you're planning.
So in medical, it's very conservative, because doctors can be sued, hospitals can be sued if they don't understand it, they don't believe it, and they're not going to understand this. So, but there's great promise for this. Some of the physicians will get it, but selling, say, into the Midwest would be really difficult, I think.
Yeah. I encountered that issue as well. Very skeptical for changing. So but like but not now, but it's like later on, like because like we cannot deny with the AI, kind of sometimes we don't use much on the AI term, but use like the data science methodology, data science techniques, data science improvement. Because like when we do, before we do, let's say, for example, like we before we just like just under like structured data we use just SQL, right? But right now the unstructured data, so we have to use like data Python, to like to do a lot of many different things. So it's improving. But if we use like SQL like long times ago, we cannot do like analyzing stuff for or building like modeling, predictive model or anything. So we have to use the data science. So just use the term of data science to avoid with like some people scared to use the term with like the AI, because many people use the term AI and AI, but like that's the data science methodology to apply in. Yeah,
And I'm used to seeing Python for this. So I mean, for basic calculations, using Python to make these calculations rather than using SQL. I mean, it's but it's going to be a learning step for them to accept and recognize that this is something that can be relied upon. So you've got a challenge there in showing them that it can be very useful, it can be easy to use, especially for you, and that the results are very quick, and they want the results to be done very quickly. So that'll be a good motivator for them to consider a change. Anyway, I'm just very thrilled with what you've been presenting, so it's very good. So thank you so much.
Oh, thank you. So yeah, if in case you need to just contact me, and then I will help you out as well. Yeah.
Thank you. There we go.
Yeah, no problem. Yeah. So now just do a little demo for this. This is for example, like I built a little app on this one, right? So let's refresh this. So let's say like the people right here is just like 35 years old and education. This I have like a sample data set of like 20 feature, 20 attribute. And I implement the generative AI in, and then generate the application like this. And for the user to use for to do on their anytime. It's a real, so anytime. And okay, this start point like 35 years old, 35 years old, and level three does mean bachelor degree, and no smokes, and cholesterol level is good. She storage is 120 standard, and this storage is like 80 standard good. BMI 24, kind of is skinny, and heart rate is 60 is good. Glucose under 100 is good. Cholesterol 60 is good. LDLC is 98 is good, and diabetes 0 in here, like yeah. So it's just like more than 8% of like risk in like heart disease. It's very general, and that's a generate for the risk factor. This one because like it's only pre-generated. And the important notes in here, just like a base predicting tool for AI, and predicted notes in here. This is a 20 feature, but we can do like 100 feature in here as well. No any issue with the under data science methodology. And I also add the preventive notes in here. Preventive notes has mean like for those attributes can control and manage by human being. Like if we smoke, we don't smoke, and then that's it good. If we less smoke, we won't have like heart disease or blood pressure as well. If we change the lifestyles, and then also we take like blood pressure medication and reduce the high blood pressure as well. And cholesterol, we can like change the eating habits or diets and do exercise, and then we reduce this as well. And BMI, the weight loss, and glucose, diabetes, like we don't eat with a lot of sugar, and then it's controllable. And this is controllable heart rate as well. So this means like preventive notes in here, so we can do like when we see it's high, let's say like okay, the age uh, for the people who have 59 years old to compare, you see that increase. The age increase, that means the probability increasing. And if smoking without smoke, and so now I smoke like how much? Like 47%. You see that's with the cigarette smoke, and with like total cholesterol increasing, so it's 66% of like risk for the heart disease. So yeah. So even like success, right, and without like diabetes, so you change to like diabetes, so 79% is a high risk level. So with a person have the diabetes and with the smoke and 59 years of age and have the high cholesterol high and we smoke, and that's a big problem. So this kind of app, but this means like when they okay, now this is independent app for any user you can pick to evaluate what level of their heart disease. But when this app to implement directly into the hospital setting, and then the user, let's say the patient go from visit the cardiologist doctor office, and then go from the beginning to the end, and at the end the doctor open the app and see the result right there. Okay, hey, Mr. Nguyen, you already like predicted like you have like 20% of like possibility to diabetes. So now, 20% of like heart disease, like heart attack or something. And then I see you smoke in there, so you smoke. So that's mean like okay, reduce smoke, and then if you reduce smoking by 20 pieces per day, and then you reduce like 5%, something like that. So that's mean like the doctor I have the records inside the hospital already, and my measurements for the time I go to the office, the new measurement, it's like it adapt inside it's retrieved from the data through the app, and the app is show up to the result to the doctor in front of the doctor, and doctor say right away. So the doctor don't need to like do the evaluation or calculation, anything. The application already calculate for the doctor already. So and then the most important is the accuracy. It's 98% of accuracy. It's like some other application out there already have, but I already evaluate just like 7 to 75% accuracy. So a lot of difference with this methodology, data science methodology. Yep, that's like kind of my presentation today, and thank you very much for your present over here. So any question, and then I'm happy to answer first.
Yeah, I remember the doctor will ask about the family history. If the person's parents have stroke or heart disease, then this patient may highly has the disease.
What can the relation between the parent and the
Yeah, the family history of heart disease.
family? Oh,
Yes. Yes.
With for that detection, I don't have that data, or to do like to apply the methodology, these model on that data. I don't have that data. So if I have that data, so that's like can calculate the relevancy between the, that's a one of the feature, one of the like attributes inside the data. So if like, I believe like EHR data in the healthcare system, it have that value. So when this model connect with EHR system, it can calculate us the relevancy between the kind of family history. Yeah, it can do that one as well. Yeah.
Thank you.
On your list there, I didn't see alcohol. Yeah, you mentioned about smoking, which is quite powerful. I wonder that alcohol is not another important feature.
Yeah. 9 of my data sets, I don't see the alcohol in there. Lovely, yes, but yeah, it doesn't have, but it have, it's relevant. It's relevant, absolutely relevant with like heart disease. Yeah. Yeah, thank you for it. Yeah.
Yeah, thank you.
Yeah.
I think that for physicians, if you're presenting this to physicians, they do that calculation mentally when they look at the patient. So something that would be good would be to show them, like if you were to examine some of these calculations, say from an ultrasound system or some of the test values from blood work, that would help them pull a number of different things together that would give them the ability to evaluate the patient I think a bit better. It's because not everyone does the calculations the same way, but they need to consider it. So having some more technology involved that would be specific to the physician, I think would be very helpful and would help you sell this. So because the basic stuff, how much do they weigh? How old are they? All of that. The doctors are doing that in their head, from the time that they see you. But something that they had to get a result from an ultrasound system, from an MRI, from a CAT scan, they need to have that information. So if that could be integrated, that would help them greatly, I think. But
Yes.
you can ask them and see if they would be interested.
Yes, absolutely. That one is like relating to like my next step to implement it's called a transformer model in order to transform, because like when we use the CNN, is that model is very good for the images, and the transformer in order to translate the result into the kind of transformer, the ChatGPT, the T is the transformer model. So that's one of the top model of the data science right now is transformer. So the transformer and the CNN can be like very good for reading and understanding and get the result for use in the MRI or CT scan image. Like my next step is like I work with like cardiologists in order to get that data sets. Data sets mean like the images, the image of like the patient who take the MRI with their heart. Let's say like frequency, like the first month and 3 months after, or every month, or quarterly, or 6 months by 6 months. And then when we have the data sets of like all images of that patient and gradually, and then we can apply the model, transformer model, and with the CNN model stacking together, and we will have the good result for it's kind of the same way like this. Yeah, thank you for question 4, but that's like exactly what I'm thinking and then working on with the cardiologist right now.
So it's already on your roadmap. So that's a good, yeah, great.
Yeah. Yes, and again, like for everyone here, like want to connect with me, like I'm happy to connect, in order to help out and work out and to implement something like meaningful for our society. Yeah.
Yeah, get a good comment. Nice work showing how much GAN and ensemble learning can improve the performance. Thank you for your sharing. That's a good comment.
Yeah.
And can you share your slides? Maybe you can send me the slide to me and I can forward.
Yeah. I will do.
Thank
Yeah.
you.
Thank you.
This is great.
Yeah. Thank you. Thank you, everyone. Like, yeah. Just let me know and let Helen know if you need anything or want to connect. Yeah.
Yeah. May I just say amazing work. Thank you so much.
Thank you. Thank you,
Yeah.
everyone. And have a good evening and afternoon, everyone. Yeah.
Thank you. Goodbye.
Thank you so much.
Bye now. Yeah. Thank you.